Welcome back, y'all. This is week 4. My name is TG Sido, and today we're going to talk about loops. Let's get started. Okay, so what did we do in the past? We talked about built-in functions, input, print, variables, infloat string boolean, mathematical operators, comparison operators, stern and functions, logical operators, expressions, and conditional statements. What are we doing today, y'all? All right, so we're going to do for loops, break, continue, variable shortcuts, and while loops. So now for for loops. What exactly is a for loop? What are we doing here? A for loop is a mechanism that actually helps us execute code multiple times. Today we will focus on a for loop using range. However, we will get to for each style loops involving strings, lists, dictionaries, and other iterable objects. So let's actually illustrate this concept with an example. Okay, so we have for I in range of 3. And then inside here we have print, hey, what's up, print I, what's going on? So over here in orange, we actually are looking at the body of the loop. What is the body of the loop? These are the statements that will actually be executed multiple times, and note the indentation in red. And so each pass through the body of the loop is actually viewed as a single iteration. So every single time we get to actually execute these statements, that can be viewed as an iteration. And this range of 3 is actually telling us that we can execute the code inside of the body of the loop 3 times. And what is I doing? You're probably wondering about that. Also, what role does in range of 3 actually play here? So what is happening with I range? So range of 3 creates a sequence of numbers from 0 to 2 inclusive. More explicitly, range of 3 produces the following sequence: 0, 1, and 2. All right? And so how does I actually interact with that? So based on that sequence, I is actually going to take on the value 0 in the first iteration. It's going to take on the value 1 in the second iteration. And it's going to take on the value 2 in the third iteration. I know that's a little bit confusing. Don't worry about it. We're going to make this a lot clearer. So again, we can actually have 3 iterations using range of 3. So when we take when we enter the for loop for the first time, I is actually going to take on the value 0, and the first iteration will begin. So over here we have our I taking on the value 0, and then we print out, hey, what's up? Then print out I, so we see a 0 on the screen. Next, I is actually going to take on the value 1, and the second iteration will begin. Now we enter again, and we actually print out, hey, what's up? Then print out I, so we have a 1 on the screen now. Finally, I will actually take on the value 2, and the third and final iteration will begin. So we go down here, print, hey, what's up? Finally, print I. What is I? It's 2, so we see a 2 on the screen. So that's what we're doing here to actually execute this code multiple times. Okay, guys, let's do a deep dive into the range function. How does this work? So range of n, we're going to specify one number over here. In our previous example, we used range of 3. And that gave us the following sequence: 0, 1, and 2. So for any positive integer n, range of n is actually going to give us the following sequence: 0, 1, 2, all the way up to n minus 1. Okay? And the assumed step or increment is going to be positive 1. And note that n is not included. Okay. And now if we specify 2 numbers, k and n, we're actually going to count up from k to n. And we're going to make the assumption here that k is actually less than n. And again, the assumed step or increment is going to be positive 1. So range of k and n produces the following sequence: k, k plus 1, k plus 2, all the way up to n minus 1. And so here's some examples. Range of negative 2 and 5 is going to produce the following sequence: negative 2, negative 1, 0, 1, 2, 3, 4. Remember, not including n, which happened to be 5 in that case. And then range of 10 and 12 is going to give us 10 and 11. Okay. So what happens when k is actually greater than or equal to n? In the previous case, we said that k was less than n. Okay, so that's actually going to produce the following empty sequence, no numbers. Let's look at a little example. So range of 10 and 8, what happens here? So this gives us the empty sequence. Why is that? There's no pathway actually from 10 to 7 in positive increments of 1, right? You can't do 10, 11, 12 and suddenly make your way back down to 7, right? You'd actually need a negative step to count down, to do 10, 9, 8, right? And so the assumed step here is always positive 1, which is why we get the empty sequence here. Okay, so now if we specify 3 numbers, we can actually have a step. That'll be the last one. And so let's assume that step is actually greater than 0. So we're actually counting up in a step that's greater than 0. And this is going to produce a sequence of all the numbers with this formula, k plus I times step, where I is going to be greater than or equal to 0, and k plus I times step is going to be less than n. So basically all the numbers in this sequence will be less than n. So we're counting up from k to n with this step size. So over here, range of -1, 11, and 3. So we're counting up from -1 to 11 in hops of 3. And it's going to produce the following sequence. -1, 2, 5, and 8. Why, right? Let's start off with -1. Let's add 3. That's our step size. So we get 2. And now let's add 3 to 2. So now we get 5. Now 5 plus 3 gives us 8. And now 8 plus 3 gives us 11. Is 11 included? What did we just say about the condition? We said that all these numbers must be less than n. What's n in our case? 11. Is 11 less than 11? No, it's not. 11 is equal to 11. So we cannot actually include 11. And that's why we don't see it up in our sequence over here. Okay. And now for the actual code, for I in range, -1, 11, and 3, print I. And so we see all those numbers that we just discussed. Okay, so what happens when your step is actually less than 0? So if your step is less than 0, we're still going to have the same formula, but the condition is going to be a little bit different. So k plus I times step, where I is greater than or equal to 0, and k plus I times step is going to be greater than n. So in this case, all the numbers in the sequence must actually be greater than n. Remember in the previous case, it was less than. Okay. So in this case, we have 10, -3, and -4. So what are we really doing over here? We're going from 10, counting all the way down to -3 in hops of 4. Okay, so it's going to produce the following sequence, 10, 6, 2, and -2. How do we get that? So let's start off with 10, and we say 10 minus 4, that gives us 6. Now 6 minus 4, that gives us 2. 2 minus 4 gives us -2, and now -2 minus 4 is -6. What's going to happen over here? What do we say? So this is -6. Are we going to include this? Let's go back. What did we say? We said that all the numbers in this sequence must actually be greater than n. Is -6 actually greater than our n, which happens to be -3? No, -6 is actually less than -3. So because it's less than, we can't actually include it. And so we'll only have the 10, the 6, the 2, and the -2, and that's why we see that in our sequence over here. So here's the code for that. And we'll see all those numbers that we just discussed. Hey there, if you're getting value out of this series, please be sure to like and subscribe so you can see all the content coming out of this channel. Thank you guys. And now for break and continue. Okay, so the break statement, what does it do? It actually allows us to jump out of the loop immediately whenever executed. Okay, so now for scenario 1, we'll get to break, but we'll do this easy scenario first and foremost. All right, so write a loop to iterate over and go over all the numbers from 0 to 5 inclusive and print them out. So if we need all the numbers from 0 to 5, how can we do that? From the previous range section, we know that if we specify range of n, and n is a positive integer, we'll get all the numbers from 0 to n minus 1. So we need all the numbers from 0 to 5. Let's use range of 6. So for I in range of 6, let's print out I. And so that's why we'll get the 0, 1, 2, 3, 4, 5. And finally, when we're done with the loop, we'll print out done, and we'll see done in the output as well. All right, so now for scenario 2, where we actually use break. All right, so write a loop to iterate over or go over all the numbers from 0 to 5 inclusive, printing them out as we go. However, jump out of the loop once we reach 3, and be sure not to print 3 out. So for I in range of 6, in the beginning, I is going to take on the value 0 in the first iteration, and we're going to check this condition, right? Is I actually equal to 3? 0 is not equal to 3, so we won't enter in there. We'll simply print I out, and so that's why we see 0. In the next iteration, when I is 1, the same thing happens, and so we end up just printing out 1. And then in the next iteration, I will be 2. Same thing, we just print out 2. And then finally, in the next iteration, I will actually be equal to 3. This condition will be true, so we will actually have to enter the if block, and then break will be executed, jumping us out of the loop completely. And so finally, we end up just printing done, right? We won't see 3 and we won't see the rest of the numbers. And so over here, continue. How does this work? Continue actually allows us to skip to the next iteration of the loop. So write a loop to iterate over, go over all numbers from 0 to 5 inclusive, printing them out as we go. However, skip to the next iteration of the loop once we reach 3 and be sure not to print 3 out. So again, for I in range 6, and we know when I takes on the value 0 in the first iteration, this condition will be false. We go over here and just print out I, so we get 0. Same thing's going to happen in the next iteration when I is actually 1. So we see 1 over here, same thing in the next iteration when I is 2. And then finally, when I actually takes on the value 3 in its iteration, we will see over here that this condition will be true. So we will actually enter the if block. And when we execute continue, it's actually going to skip us all the way to the next iteration. So we will not actually hit print I, we'll just simply skip to the next iteration, and now I will take on the value 4. And so when I takes on the value 4, it'll check this condition again. This condition is false, right? 4 is not equal to 3, so it'll simply go down here and print out I, so we will see 4. And then same thing happens when I takes on the value of 5 in the next iteration, and then finally we print out done. Note that we do not see the 3. Why do we not see the 3? That's because when we continue, we skip to the next iteration and we weren't actually able to go down and print I, which is why we don't see 3 in the output. And now for some variable shortcuts. Okay, so num is equal to 10, we see that over here, and now num plus equal 1, and now suddenly num is equal to 11. What happened? So num plus equal 1 is actually equivalent to num is equal to num plus 1. So we take whatever's in num at that point in time, which is going to be 10. We're going to say 10 plus 1, that's 11. Now let's put that back into num, so now num updates to be 11. Okay, now over here num is equal to 10, we see that. And now num minus equal 3, and now we see num actually is 7. So what happened? So num minus equal 3 is actually equivalent to num is equal to num minus 3. So we take whatever's in num at that point in time, which is 10. So 10 minus 3 is 7. Now let's put that back into num. So num is 7. Awesome. So now num is equal to 10, and now num times equal 2. And now we see that num actually has an update. Now num is 20. So what happened here again? This is actually going to be equivalent to num is equal to num times 2. So we take whatever is in num at that point in time, which is going to be 10. So 10 times 2 is 20. Now let's put that back into num. And so that's why num is now 20. All right, now over here, num is equal to 10. Num divide equal 2. And we see that num gets updated to be 5. What happened here? Again, we see that this is equivalent to num is equal to num divided by 2. So we take whatever's in num, which is going to be 10. 10 divided by 2 is 5. Let's put that back into num. So now num is 5. And now for while loops. Let's get started. So what is a while loop? Like the for loop, the while loop is a mechanism that helps us execute code multiple times. Note, however, there is an explicit condition which must be true to continue execution. Let's illustrate this concept with an example. All right, so we have over here a while condition, and then we have inside of the body of the loop statements A and B, and then finally outside of the loop statement C. Scenario 1. Condition is true before we actually reach the while loop. Okay, so since the condition is true, we'll actually enter the body of the loop. And now we're going to execute A. Next, we'll execute B. And now over here, having executed the code in the body of the loop, the condition is checked again. If the condition is still true, we'll actually return to the top of the loop body and actually execute A again. However, if the condition is now false at this point in time, we'll actually jump out of the loop and execute C. And now for scenario 2. The condition is false before we even get to the loop. Okay, so since the condition is false, we will not enter the body of the loop. We'll simply skip the loop and hop to the next statement, which happens to be C. All right, okay, so now for an example. So num is equal to 0, we see that over here. And now our condition is num is less than 3. So is 0 less than 3? Yes, it is. It's true, so we can actually enter the body of the loop. So we print out num. We see 0 on the screen. Next, we're going to increment num. So now num is going to be 1. And now we need to check the condition again. Is 1 less than 3, right? Is num less than 3? Yes, it is. So we can actually go back to the top and we'll print out num. So we see 1 on the screen. Next, we'll increment num. So now num becomes 2. And now we need to check the condition again. Is 2 less than 3? Yes, it is. So we can now go back to the top of the loop. And we'll print out num again, which is 2 at this point in time. So we see 2 in the output. And now we're going to increment num again. So now num is 3. Now we need to check again. Is the condition still true? Okay, is num less than 3? Is 3 less than 3? No, right? 3 is equal to 3. It's false. The condition is false. So now we need to jump out. And we'll finally print done. Okay, so when do I use a for loop? When do I use a while loop? How do I make the determination? So while is typically used when you need to loop for an unknown or unspecified number of times, and for is typically used when you know how many times you'll need to loop beforehand. Hey, we learned a ton today. Stay tuned for the weekly workshop. We're going to put all this into practice, and we have more lessons coming soon, so stay tuned for that as well.